We'll talk about a very important part of the vector arithmetic, and that is dot product. Okay, vector. So multiplying two vectors. We have seen already. If we multiply with a scalar, only the magnitude gets increased. Now we consider about vector multiplication. The one is called dot product, where A and B are two vector, and they have a dot in the middle showing the dot product. And vectors, two vectors can be multiplied in another way, which is called a cross product. And we'll talk about it later if necessary, but currently we just focus on the dot product. Okay, so let's see a vector in a three-dimensional space which has three components. A has three components: ax, ay, and az along the three different axes, x and y and z. Okay, similarly B has bx, by, and bz. Now A dot B, which is the dot product of vector A and B, are nothing but the simple multiplication of the x component of A and x component of B, y component of A and y component B, and so on. And then we add those components, and then we'll get a single number. Okay, so we have to remember this, very important, that the dot product of two vectors is a scalar quantity, is not a vector but a scalar quantity. Okay, so because this is a simple multiplication, so it can be commutative and distributed. This property simply hold. So like A dot B equal to B dot A, because for multiplication intuitively this property holds. Multiplying 2 with 3 and 3 with 2 have no different effect. Similarly, distributive property also, like A dot B plus C equal to A dot B plus A dot C. Okay, so similarly now we if you multiply it with a scalar, let's say C times A dot B equal to C times A dot B as well. Okay, so it will be equal to C times B dot A. So these are all similar. So now you see we take a vector which has two components, x and y, 3, 1. This is a previous vector we have already seen, and there's another vector B with two components around x and y, and then we do a simple dot product. So we multiply 3 with minus 4, 1 with 2, and then we get a minus 10, which is a scalar quantity. So we have seen dot product, and now we see a graphical representation of dot product. Some more operations on dot product. Dot product, as we have already seen, A dot V, two vectors. So it's the sum of the corresponding component in A and B. So let's say A is AX, AY, and AZ, and B is BX, BX, BY, and BZ. Then AX and BX we multiply. So the corresponding component we multiply, and then we sum up over all components. This is one way of representing cross product. Okay, so we have done A dot A here. You see two variables, two vectors which are exactly same. So we multiply AX with AX, AY with AY, and then we find out this is nothing but the mod A square. That means the mod A means the magnitude of A and the square of it. As we know that the dot product produces a scalar quantity. So A dot 0 will be 0 because the 0 vectors, all components are 0. So if you multiply something with 0, it will become 0. And now you see there is another way of representing cross product. Okay, so dot product, which is A dot B, which the way of this is called a theorem. So which is A dot B, two vectors dot product is mod A times mod B times cos theta. So let's see this picture, this the blue arrows. Okay, A is the vector A, this is B, the vector B, and they have the angle theta in between them. So we can see that the A dot B will be given by mod A times mod B times cos theta. That is the angle theta in between them and the cos of that, cosine of that. So so if this cosine is 90 degree, then we know that cos 90 degree equal to 0. So we can see that A dot B will then be equal to 0. So now we can also match it with this way. So this was calculated using this formula, and now using this theorem, if we calculate A dot A, okay, so you see mod A times mod A times cos 0, because two vectors are in the same direction, A and A, so that the angle between them is 0. So A cos 0 equal to 1. So this will become mod A square. So both the formula we can see gets in the same result. Now you see, if this angle between the vectors is 90 degree, that means they are perpendicular to one another, what will happen? their impact, their dot product will be 0 because cos 90 equal to 0. So they are called orthogonal vectors. Okay. Now, how I come into this formula? This is a very important formula. We'll be using it for many things. We can calculate the angle between the vectors using this formula. Derive the cos theta a dot b divided by mod a times mod b. Now, how I come to this formula? So I come to this formula using the law of cosine. Law of cosine is taught in the high schools, I guess. So what is law of cosine? It says if you know two vectors, then the third vector, which is like this, c. Okay, so c, if you know this one and the angle between them, then you can calculate c. So it says mod c square equal to mod a square plus mod b square minus 2ab cos theta. Okay, so if you know this and the angle between them, then you can calculate the value of c. Now, let's identify this as equation 1. Okay, so we want to relate this with something else. Now we also want to calculate mod c square using this way. Okay, so how we are doing, you see, mod c square is nothing but c times c. Okay, so here you see c is also a minus b. How we calculate a minus b? You have already shown the vector subtraction. So you see, this is the vector b. We take up the opposite of vector b. The direction will be opposite, the magnitude will be same. We call it minus b. Now we slide it over this and match it with the tip of a. So now this is minus b. So this one now from the tail of a to the tip of b is nothing but c equal to a minus b. So if you can consider, this is the parallelogram. So if this is c, this is c, and this is c, also this is c. So c is nothing but mod a minus the vector a minus vector b. So if we do c square, c times c, so this is a minus b times a minus b. And if we just expand, a times a minus b times a minus a times b, and minus plus b square. So this will be square plus. Okay, so b times b. Now you see mod a times mod a, we already know this is mod a square, so we put mod a square. Similarly mod b square. But how can I write minus 2ab for b dot a and a dot b? Because we have already seen that vector, the dot product is commutative. So a dot b equal to b dot a. So this is b dot a, so we can equate with a dot b, and then we can write it's minus 2ab. Okay, so now this is equation 1, the cosine rule, and this is equation 2. If we equate both of them, we'll find out this thing. So it'll be cancelled out, mod a square and mod b square. We'll see minus 2ab cos theta equal to minus 2a dot b. So a dot b is nothing but a mod b cos theta. So this is the derivation of this formula. In normal, other existing places, you will not see that. I have already shown you the derivation of the formula. And now we'll use this formula to do some problem exercises which will help you to understand. Here we see an example of dot product. We have already seen that a dot b will be mod a times mod b times cos theta, and we can also calculate their dot product using the corresponding items of two vectors are multiplied and then summed up. So we have a vector a with 3 components x, y, z, and a vector b with 3 components. Now we want to calculate the angle between them, the theta, and the dot product of the two vectors. So first we calculate the magnitude. So the magnitude will be square root of the component x component square plus b y's component square and c or the z component square. And then we get root 46, and for mod b, we get 7 square minus 5 square plus 1 square, which is 5 root 3. And then a dot b is now of them and find minus 28. So this is a dot b, the answer of this. And then we also find the angle between the vectors using this cos theta, this formula. So a dot b, we have the value, so minus 20, then divide by mod a times mod b, which is 5 root 3 times root 46. After simplifying them, we find it minus 0.48. Okay, so now the theta will be cos inverse of minus 0.48, which is 2.07145 radians, and which in degree converts to 118.69 degree. So now we know that the angle between these two vectors is around 119 degree.